But eventually it gets used up by the plants. And the Everglades themselves are a phosphorus-limited ecosystem. Okay, and as this phosphorus coming out of the sugarcane fields is what led to the 1988 federal lawsuit suing the federal government sued the state of Florida for allowing the sugarcane farmers to pollute the Everglades. Okay, and that was one of the things that led to what we call the Comprehensive Everglades Restoration Plan. I'll come back to that in a little bit. Okay, but notice that phosphorus gets taken up long before it ever makes it to Florida Bay. And so remember, you saw really low phosphorus in eastern Florida Bay. Now here, the blue is the nitrogen. And I've adjusted the scales differently, such that, for the nitrogen and phosphorus, such that if the nitrogen and phosphorus was in a 16-to-1 ratio, those two lines would be on top of each other. So it tells you there's a huge excess of nitrogen. In fact, the nitrogen-phosphorus ratio coming out of sugarcane fields is like about 100-to-1, 200-to-1. Huge excess. Now you might initially think, well, that's fertilizer too, right? But I mean, the phosphorus is. Sugarcane farmers obviously have to fertilize their crops, okay? So they're fertilizing it. But no, if you're a farmer, are you going to add, if you know the plants need nitrogen and phosphorus in a 16-to-1 ratio, are you going to add fertilizer in a 100-to-1 ratio? No, you can obviously see your fertilizer is just running all the way off down to Florida Bay. You're wasting your money, right? That's not fertilizer, okay? Turns out that's natural as well, okay? Okay, we have to understand the history of the Everglades here. You think of Florida as being very flat, in which you'd think the water would flow to the west and to the east. Well, in fact, Florida's not completely flat. For geological reasons I won't go into here, we've got what's called the Atlantic Coastal Ridge right along the coastline here. And then we've got the Lake Wales Ridge down the center here. And then there's a trough in between those two ridges. And that's what sets up the watershed for the Everglades in South Florida, okay? So the water starts up here just south of Orlando, and it's channeled between these two ridges and flows all the way down through the Kissimmee River Basin into Lake Okeechobee, and then down through the Everglades into Florida Bay. Here, you're looking at it from the side. So here's your ridge, another ridge here, and you got this trough in the middle, okay? Well, that used to be dry, but then as we came out of the last ice age, as sea level's rising, it's getting warmer, and you're getting more moisture in the air, you start filling this trough up with water. That's how you form a wetlands. That's how you form the Everglades. The Everglades began about 5,000 years ago. You eventually fill up this trough, okay? Now what happens in wetlands are really good nutrient sinks. Okay, the plants grow, they die, that organic matter sinks down to the bottom, it goes anaerobic, and you preserve that organic matter as what we call an organic peat, or sometimes called a muck. And it's extremely rich in nitrogen. So over the course of 5,000 years, you've completely filled up this trough. So you go out there now, well, I think my next slide shows this, yeah. So in various places, you've got up to 15 feet of organic peat. It's like 99% organic material. It's not your normal soil, it's not minerals, it's organic peat, okay? As long as it's underwater, the organic peat is stored up and it remains there under anaerobic conditions, okay? The problem is, as soon as you drain that land, you drain the wetlands, expose the organic material to the air, bacteria decompose that organic matter, turns into CO2. So the organic matter just goes into the air as a greenhouse gas and releases that nitrogen. So in fact, what's happened by draining the Everglades, we've released 5,000 years worth of nitrogen in the last 50 to 100 years. That's the source of nitrogen. If you want to stop that source of nitrogen, you've got to reflood the Everglades. Well, it used to be the Everglades. You've got to reflood what's now sugarcane fields.
Okay.
This also leads to what we call subsidence, okay? For example, this was the surface of that organic peat at this location in 1927. And almost a century later, that's the surface of the soil. You've lost all that organic peat. And all the associated nitrogen flowed right on downstream, okay? Here's another picture, a house built in 1930 out there in the Everglades. Well, that was the surface of the soil in 1930, and all the soils disappeared below them. So every few years they have to add another step to the stairs here to get up to the front door. Okay. So let's look at the history of sugarcane farming in the Everglades, northern third of the Everglades. It sort of puttered along the first half of the 20th century. And then after 1959, it shoots up about tenfold. Okay. What happened in 1959? Well, that was the Cuban Revolution. Okay, middle of the Cold War, U.S. government's not happy having a communist dictator only 100 miles to the south, so they proceed to try to get rid of Fidel Castro. The Bay of Pigs didn't work too well, exploding cigars didn't work, et cetera, and so they decided to try to destroy the Cuban economy, which at that time was primarily sugarcane. So they set up a complex array of tariffs and subsidies, et cetera. The bottom line is the sugarcane or the sugar industry in general is now subsidized to the tune, depends on how you calculate, maybe $2 to $5 billion a year as a way of getting rid of Fidel Castro. And of course, you know, still after all these decades, we continue to subsidize this as if it's going to get rid of Fidel Castro, right?
Definition of stupidity.
Well, let me back up. Okay, so we see this huge increase starting around 1960, but the algal blooms didn't start until around 1981. So what happened? Oops. Well, in fact, what they did when they decided to drain this huge area for agriculture, the Army Corps engineers came in, there's these huge dikes and so on, they actually reversed the flow of water in South Florida. They installed these giant pumps on the southern side of Lake Okeechobee, and they take all the runoff from the sugarcane farms and pump it up into Lake Okeechobee. And of course, you have to then drain Lake Okeechobee, so they enlarged the Clusatch River to the west, and they dug the St. Lucie Canal to the east to pump the water out those directions, rather than the water heading south. Okay. Well, not surprisingly, it didn't take too long. You start seeing all this nutrient-rich water going into Lake Okeechobee. You start seeing algal blooms, and then fish kills, and eventually lawsuits. So right around 1980 or so, they said, well, we can't do that anymore, so we'll reverse the flow of water again. So around 1980, 81, they start pumping all this water south. And I'll just show you data. Here's a station here, halfway between the sugarcane fields and Florida Bay down here. Okay, here's the flow of water from 1962 to 80. You see very low flow. Now, you know, some years you have hurricanes, so you have some flow, but very little. And then with the policy change around 1980, 81, you see this large increase of water going south. And here's the actual water going into Florida Bay, same thing, low until around 1980, 81, and then a large increase. There's a drought in 1989, 90, and then even larger. Okay. Well, we don't have data from back then when those blooms first started, but the fishermen are out there every day. They can see what's going on. Okay, and so Karen DeMaria interviewed a bunch of these fishermen and said, well, from 1981, the water started getting cloudy. We started having a hard time seeing the bottom. The water got dirtier, the blooms grew, and the seagrass started dying. Okay, from 81 to 86, the decline was gradual. And then 87, bay collapsed. That's when the seagrasses died. Massive seagrass died off in 87, but the blooms began in 1981. This will become important in a second. Fishermen saw the water first by becoming dirty, then algae blooms started, and then seagrass died off. Now, just to demonstrate this, here's salinity, how salty the water is during that drought of 1989-90. So you see blue is high salinity, orange is low salinity. So you see very little fresh water getting in the bay during the drought. Come out of the drought, and your high salinity goes away, and you see all this fresh water coming into the bay. Okay? Then during the drought, that's the salt. Here's the nitrogen. Here's the amount of nitrogen in the bay. You see during the drought, when there's very little fresh water coming in, there's very little nitrogen coming in. Now you start pumping a lot of fresh water in from the north into the bay, you pump in lots of nitrogen. And of course, where that nitrogen mixes with the phosphorus in the west, that's where you're going to generate your algal bloom. Okay, so I'm going to show you data at these 4 stations here. Here's 15 years worth of data. And you know you have a very distinct wet season, dry season cycle. So blue is the amount of water flowing into the bay, and green is the size of those algal blooms. So here we just average it out month by month. So blue is water flowing into the bay. So here's our dry season, and here's our wet season. Green is the abundance of the algae. Here's our dry season, and here's our wet. A little bit of a delay. It takes a while for the algae to grow, but you can can see very good correlation there. That's actually total algae. This is specifically blue-green algae. Basically, it tells us that that bloom is almost all blue-green algae. You see the correlation there with runoff. That's on a seasonal basis, but you also have long-term changes. We have wet years and dry years. So we just look at annual averages. So here's some wet years here, and here's some dry years here. So again, you see that correlation. Okay. Well, a lot of people were not happy with my conclusions. I was showing a linkage between the algal blooms in Florida Bay and the total ecological destruction and agricultural farms to the north. And politicians get a lot of money from these agricultural people, so a lot of people were not happy with this. So they hired some people to, and they looked at the exact same data set I did, and they concluded no correlation whatsoever between algal blooms and the runoff into the bay.
Prove it.
Well, and we use the same data set. Now, how could that be? Okay. Turns out they didn't lie. But it turns out neither of us used the complete data set. The complete data set for Florida Bay includes all these stations over here, all these. I took this data at these 4 stations here. They took the data from the stations in blue. In other words, I took the data where the bloom is. They carefully select out just the data where the bloom doesn't exist. Okay? Because it's not nitrogen limited over there. So they didn't lie, but you have to read the details. Like they say, oh, we didn't see a correlation. But if you look at their method, the fine print, you can see how they treated the data. It's clearly very dishonest. Okay. Okay, another scientist who now works for Boat Marine wrote a paper, and they said, well, Florida Bay annual bloom biomass in the maximum is in the summer and fall, maybe early winter, and the wet season. I agree, absolutely correct. But then they say in Florida Bay, most of the blooms tend to occur in the dry season. Wait, summer and fall is a dry season? And no instances of maximal algal biomass during the wet season of April through June. Well, yeah, June is the beginning of the wet season. April and May, exactly backwards. And this person lived in Florida for many years. They got to know what the wet season, when the wet season, dry season is. This person now runs the Red Tide program for Boat Marine. Okay? But this is the kind of things they do to attack me, okay? That's the kind of games they play. Say there's no connection between agriculture and algal blooms. Okay, well anyway, as I mentioned, there was this, when this water moved south, you started seeing all these ecological problems to the south, that led to the federal lawsuit and then led to what's called the Comprehensive Everglades Restoration